Hello dear students, this video is divided into two parts. In the first part, I explained surface area of combination of solids. In the second part, I solved exercise 13.1 question number 1 to 4. In the previous video, we have discussed so many formulas, that is TSA, CSA and volume of many solids. Okay. See, in the problem, if we are getting a problem for a single solid, you can definitely apply that formulas directly. But in some cases, okay, that figures may be combination of solids. Such figures we are going to discuss in this video. That is TSA or surface area of a combination of solids. Combination of solids means sometimes it may be a hemisphere and a cylindrical portion may be surmounted, okay, on this hemisphere. Okay, and from this it is very clear the diameter of the hemisphere is same as the diameter of the cylindrical portion. Understood? So, in order to get its surface area, okay, what is the formula? We don't have the single formula. That means we have to find out the CSA, okay, the CSA of the cylindrical portion, okay, cylinder plus CSA of the hemisphere. Okay, this will give you the total surface area of this form, this solid. Understood? And sometimes it may be of this type. Okay, here instead of hollow cylinder, it may be cone. Okay. Okay, in the second figure, it is very clear a conical portion is surmounted on the hemisphere. And how to find out the TSA of this solid? Find out the CSA of the cone, that is pi RL plus CSA of the hemisphere. Is it clear, children? So, in the next combination may be of this type. Okay, that just like a capsule form, that is one cylindrical region, okay, and both ends, okay, what is it? See, that is a hemisphere is attached at both ends. Okay, so what will be the TSA of this solid? That is, you have to find out that is CSA of the cylindrical portion and CSA of two hemispheres. Okay, that is CSA of the cylinder is 2 pi RH plus 2 into 2 pi R square. 2 pi R square is the CSA of the hemisphere. That is, we have two hemispheres. So, 2 into 2 means, that means 4 pi R square, or together it will make a sphere that, and its TSA is 4 pi R square, or in this manner both are the same. Is it clear, children? And in the next case is in the shape of ice cream. Okay, see, imagine an ice cream, cone ice cream. So, this is a cone, okay, and see this. Okay, what is the TSA? This is another shape combination, that is a cone and a hemisphere is surmounted on the conical portion region. Okay, so CSA pi RL plus hemisphere, that is 2 pi R square. Understood? Or in case of top, this is also top. Okay, so these are the different forms of combination of the figures. Okay, that is a combination of the solids. Okay, so in that case we have to split and add the CSA, and that will give you the TSA of the required solids. Okay, this is all about the surface area of combination of the solids. Okay, so let us move to exercise 13.1, problem number 1. In this question, we have given two cubes that are joined end to end. Okay, that means when you join two cubes together end to end without overlapping, exactly coincide. Okay, two cubes of same side, same edge are joined end to end. That is given in the question. Okay, and the volume of each cube, is given as, 64 centimeter cube. Okay, and what is asked? We have to find out the TSA of the resultant cuboid. Okay, that means when you join two cubes together end to end, okay, its length gets changed, okay, but the breadth and height remains the same. Is it clear, children? Okay, when you join two cubes together, that means if this is the side, okay, and for the second cube this is the side, and the length of the cuboid will be A plus A. If this is A, this is also A, so length of the cuboid will be 2A, A plus A. Okay, but for cube and also the resultant cuboid having the same height, okay, that is A, and breadth also A. Okay, this all remains, the other two dimensions, that is breadth and height, remains the same. Okay, so we have to first find out what is the side, that is the side of the cube, that is A. Okay, so that you can apply the TSA of the cuboid and you will get the total surface area of the resultant cuboid. Is it clear, children? Okay, so for that, since we have given the volume of the cube, each cube is 64 centimeter cube, from this we can easily calculate the side of the cube. Is it clear? Okay, so volume of the cube we can substitute as A cube, that is equal to 64, or in order to find out the A, that is edge, the side of the cube from A cube, you have to take cube root on both sides. Okay, taking cube root on both sides means cube root of A cube equal to cube root of 64. In the case of square root of, okay, square and square root get cancelled, same way cube and cube root get cancelled, so A equal to, what is cube root of 64? That is 4. Okay, so we have got the side of the cube equal to 4 centimeter. Because this is centimeter cube, this edge will be in centimeter. Okay, or instead of this you can write A cube equal to 4 cube. By prime factorization, make them triplet. Okay, that way also you can find out the side of the cube. Okay, anyhow we got the side of the cube as 4 centimeter. Okay, then the remaining portion problem is very easy. That is, we have already seen the length is equal to 2A, the resultant cuboid. Okay, and breadth I already have told, breadth equal to A itself and height also A. There is no change. See, this is the height. This is the height for the resultant cuboid also. Okay, and breadth also remains the same. Okay, so TSA of cuboid. What is TSA of cuboid is equal to, by formula, 2 into LB plus BH plus LH. Children, in this lesson the very important thing is learn the formula, okay, correctly, then only you can substitute, okay, and you can reach into the correct answer. Okay, so 2 into LB plus BH plus LH is the TSA of the cuboid. We have all the three quantities are known, just substitute. So 2 into L is 2 into A, that is we have got 2A as 4, okay, so 8 centimeter, understood? Okay, so these are B and H equal to 4 centimeter each. Okay, so L equal to 8 into 4 plus 4 into 4 plus 8 into 4. There is no change for length and, there is no change for height and the breadth. Okay, so we can, if you want, you can take the common 4 from each term. So 2 into 4, I have taken 4 from each term from the bracket. Okay, so 8 plus, here 1 4 already have taken, so the remaining one more 4 is there, so 8. Okay, or you can add 32, 16 plus 32, doesn't matter. If you doing like this, it will make you little more simple. Okay, so 2 4s are 8 into 8 plus 4, 12 plus 8, 20. Okay, and 8 into 2, 116, that is 160 centimeter square. Area, both the TSA and CSA should express always in square units. So, the TSA of the resultant cuboid is 160 centimeter square. Okay. In the second problem, we have given a vessel and it is of the form a hollow hemisphere mounted by a hollow cylinder. Okay, and the diameter of the hollow hemisphere is 14 centimeter and the total length of the vessel is 13 centimeter. And we have to find out the inner surface area of the vessel. Okay, so it is almost like this form, children. So the bottom is a hemisphere and a hollow cylinder is mounted. Okay, and from this it is very clear, since the diameter of the hemisphere is given as 14 and since it is this hollow cylinder is exactly coinciding, see the figure, okay. That means the diameter of the hemisphere is equal to the diameter of the hollow cylinder. Okay, and that is can be equated to 14, that is given. Okay, so diameter of the hemisphere and that is equal to diameter of the cylinder, hollow cylinder, and that is equal to 14 centimeter, implies R is equal to 14 by 2, that is 7 centimeter. Okay, and the another important thing, the total height of the vessel is given as 13 centimeter. Okay, and since we don't have a single formula to find out the CSA of this vessel, then how it can be solved? Okay, by adding the CSA of, that means the CSA of the hemisphere and the CSA of the hollow cylinder. Okay, since the thickness is negligible, that is nothing is said about this thickness, you can definitely make use of the CSA, the outer CSA is same as the inner CSA. Okay, and we have seen in the first video what is the CSA of the hollow cylinder. Okay, since the R is thickness is negligible, that is 2 pi RH. Okay, and what is the CSA of the hemisphere? That is 2 pi R square. If you add these two, you will get the inner surface area of the vessel. Okay, but in 2 pi RH, you should get the separate height of the, that is hollow cylinder. Okay, since we have given the total length of the vessel, we have to find out exact height of the cylindrical portion. Okay, from that means you have to subtract the height of the or the depth of the hollow hemisphere. This should be subtracted. Okay, and since this hollow hemisphere, okay, this circular shape, so from this center to that means this point, that is radius, and that will be same as from the center to any point on this curve. Okay, that means both are radii. So in hemisphere, radius is same as the height, that is the depth, that is R equal to H. Okay, in case of hemisphere, this is very important, and since that radius is given as 7 centimeter, diameter is 14, implies R is equal to 7 centimeter. So height also 7 centimeter. Okay, so height of the hemisphere. So if you subtract this height, okay, that means this from this 13, okay, you will get the height of the cylindrical portion, hollow cylinder. Okay, that is the next step, that is the height of the cylinder, hollow cylinder is equal to, from the total length, that is 13, you should subtract 7. I hope that concept is clear. That means the depth or the radius both are the same for hemisphere, that should be subtracted from the total length of the vessel. Okay. So, you will get a 6 centimeter. That is the height of the hollow cylindrical portion. Is it clear? So, all the required quantities needed to solve this now it is clear. So, we can just write down the formula, then substitute the values. Okay. So, inner surface area of the vessel, okay, of the vessel equal to, you can represent with A is equal to, that is CSA of hemisphere. What is CSA of hemisphere? That is 2 pi r square. 2 pi r square plus, what is CSA? CSA of the cylindrical portion or hollow cylinder, that means 2 pi RH. Okay, this H stands for the cylinder, that we have already seen, separate height we have taken from the total length of the vessel. Okay, so from these two terms, 2 pi and also r, both radius are being same because both are exactly coincide. So radius for both shape are the same. So you will get, you can take 2 pi r common from both terms. So 2 pi r into r plus h, that is 2 into 22 by 7 for pi, and radius we have got 7, okay, into r is 7 plus h, that is height of the cylinder, that is 6 centimeter. Okay, 7 get cancelled, connected by into, so you can cancel. So 2 into 22 is 44 into 13. 7 plus 6 is 13. Then multiplication. So that is 3 4s are 12, 1 carry. So 4 1s are 4 and 12, 6 plus 1 7, 1 carry, 1 4s are 4 plus 1, 572 centimeter square. Don't forget to write down the unit, because since it is area, it is always in square units. So the inner surface area of the vessel is 572 centimeter square. Is it clear, children? Yes. In the third problem, we have given a toy. Okay, and a toy is in the form of a cone. Okay, that cone is mounted on a hemisphere, and the radius of the cone is equal to and the radius of the hemisphere. Okay, so this is almost of that form. Here we have a hemisphere and a cone is mounted on the hemisphere, and being the radius, that means diameter. Okay, the diameter of the cone and the diameter of the hemisphere both are same, that is exactly coinciding. This is almost of toy of this problem. Okay, so and what is asked? We have to find out the TSA of the toy. Okay, TSA of the toy means, in order to get the TSA, we don't have a single formula for this solid. That means we have to apply the concept of combination of solids. Okay, that means you have to add. What we have to add? Should we add the TSA of cone with the TSA of this one? No. That means this face and this face are coinciding, so that need not be considered. Okay, we have to consider only the CSA of the cone plus CSA of the hemisphere. Clear, children? That means in order to get the TSA, we have to add the CSA of the cone plus CSA of the hemisphere. Okay, and we have given the total length of the toy as 15.5 centimeter. The total length of the toy is 15.5 centimeter. Okay, and we have to find out the TSA of the toy. Okay, and as we explained, that means the CSA of the cone means that is pi RL, isn't it? So pi RL, that means where L is the slant height. Okay, that means the in the second problem, we have given a toy and it is of the form a hemisphere and a cone is mounted on the hemisphere. Okay, it is of this form, children. Okay, here we have a hemisphere and a cone is mounted on the hemisphere. Okay, see this figure. Okay, in order to make the idea a little more clear, let us look at this shape. Okay, so here the radius of the hemisphere and the radius of the cone are same, that is given as 3.5 centimeter. Since they are exactly coinciding, each the base are the same. Okay, that means the radius of both shapes are equal to 3.5 centimeter. Okay, and the total height of the model, that is toy, is given as 15.5 centimeter. Okay, and finally what is asked? We have to find out the TSA of the shape, that is toy. TSA of the toy, we don't have a single formula for that. So we have to apply the concept of combination of solids. Since it is the combination of a cone and the hemisphere, you have to find out. Should we find out TSA of cone and TSA of hemisphere? No, children, because this face and this face, circular face of the hemisphere, are coinciding. That means you have to find out CSA of the cone plus CSA of the hemisphere. Clear, children? Okay, even if the TS is asked, we have to find out CSA of the cone and CSA of the hemisphere. Is it clear? So for that, okay, what is CSA of cone? That is TSA of toy is equal to CSA of cone plus CSA of hemisphere, that is pi RL, that is CSA of cone. Learn the formula, children. Okay, that is very important. Okay, plus and CSA of hemisphere, that is 2 pi r square. Okay, 2 pi r square. Okay, here pi constant are the values given, but what is L? In pi RL, what is L? L is nothing but the slant height, but that is not given. Okay, and in the second term, 2 pi r square, radius also given, 2 and pi are constant, so no problem for the second term. So our first target is to find out the slant height of the cone. What is slant height of the cone? That is, we are usually representing the slant height by L is equal to root of h square plus r square. Here h is definitely the height of the cone. Okay, but the height of the cone is not given. Is it clear, children? The height means from this point to this point. The height should be found first. Okay, and for that, since the under that in the bottom level we have the hemisphere and radius and the depth, this height of the hemisphere is equal to radius. Okay, and that is given as 3.5. That means you have to subtract 3.5 from the total height of the toy. The total height of the toy is given as 15.5 centimeter. Okay, so height is equal to height of the cone, h is equal to 15.5 minus 13.5, and that is 12. Okay, now we can substitute here, and so that you can easily get the slant height. Okay, so L is equal to root of h square, that is 12 square plus 3.5 whole square. Okay, so we are going to solve, that is 12 square is equal to 144 plus 3.5. You just take 35 into 35. What is 35 into 35? A number end with 5. Its square also, its square is end with 25. Okay, and the remaining numbers will be getting by multiplying the consecutive number of 3, that is 4. 3 4s are 12. Okay, so 3.5 into 3.5, 2 decimal place should be shifted to left side. So 12.5. Hope it is clear. If it is 45, 25, 4 the next consecutive number is 5. So 4 5s are 20, 25. Likewise, okay. So 12.25, okay, and by adding you will have 144 and 12 are in the whole number place. So 12 and 144 is 156, 2 plus 4, 0.25. This is the slant height. And the next step is we have to take the square root of 156.25. Okay, in order to get this square root easily, I just convert it. I think the steps are clear. Okay, I just convert this into decimal number in the square root into fractional form. Okay, so in the denominator, since we have 2 decimal places, okay, so in fractional form we will have 2 0 with 2, that is 100 in the denominator. Okay, this is the equivalent, and write the numerator without the decimal point, that is 15,625 divided by 100. Understood? And what is root of a by b? Root a divided by root b. Root b is root of 100 is 10. So that means we have to find out the square root of 15,625. Okay, that is the next step. Okay, let us see how that can be easily found. That is 15,625. Square, we have to find out its square root. So from right to left you make a pair. Okay, group them. Okay, like this. So in the last group we have only one digit and take its square root. Since we have 1, square root of 1 is 1 itself. We have in detail we have studied in 8th standard. Okay, so 1 its square root. Okay, so here on subtraction you will get here 1 itself. Okay, 0, and take the double of the quotient. 1 we have. Okay, and its double is 2. Okay, and bring down the next pair as a whole, not digit by digit. We are bring down the group itself. Okay, that is 56. Now you can write a number with the right side of 2. With the same number you have to multiply the number. Okay, that is that number should come equal to or less than 56. Okay, so if you are taking 1, so 21 into 21, 21 itself, very close to 56. So we can take 2. So you with the 2 you can multiply 22. Okay, so 44, it is closer to 56. We can't take 3. If we are taking 3, we will get 69. Okay, so it should not go beyond 56, less than or equal to 56. So 12, okay, is the remainder. We can't stop the division now. We have to bring down one more group, that is 25. Okay, and in the next step, here we have 2 we got here in order to get 44. And for the next case, we have to take the double of 12. Okay, that is 24. Okay, so we have to write a number to the left of 24. Okay, and with the same number you have to multiply in order to get a number equal to 1225 or less than 1225. Okay, and since we are expecting a square number and ending with 5, I am just taking 5, so that if you multiply with 5 you will get 5 in the unit place. So 2 remainder. Okay, 20, 22. Again 2 remainder, 10 plus 2, 2. So exact number. So 1225 and the remainder 0. That means the division stopped. We have no group to be bring down further. Okay, so 125 is the square root of 15,625. Is it clear, children? Okay, so here root of 15,625 divided by root 100. Okay, and you can write this as 125 divided by 10, and that is 12.5. 1 point should be shifted to left side in order to divide with the 10. Okay, so 125 become 12.5 when you divide with the 10. Okay, so that is the slant height of the cone. Okay, why we have found all this? In order to get the TSA of the toy, you have to add CSA, that is pi RL plus 2 pi R square. Then there we need the slant height, and now we have. The next step is just a substitute, and you can easily reach into the final answer. So the slant height of the cone is 12.5. Okay, and now see the formula, that is CSA of the cone equal to pi RL plus 2 pi R square, and from these two terms, okay, before you substitute, take the common factors, and finally in the last step you can substitute the values. Okay, that will make you little more easy. The steps will be easy for you. Okay, so to pi R and here also pi R being radius same, you can take pi R common. So in the bracket you will have L, okay, plus 2 is there, we have taken only pi R, so R square is there, so R will be there, and 2. So 2R remains in the second term. Okay, so in the next step only we are going to substitute the values. Okay, so 22 by 7 for pi, and radius is equal to 3.5, that is common, okay, into slant height we have seen 12.5 plus 2R means radius, diameter, right? So 3.5 into 2, that is 7. Okay, so these are the numbers comes in the bracket. Now we are going to solve this. Okay, so either you can 3.5 can be written as 35 by 10, or 7 in 3.5 is 0.5, doesn't matter, or 35 by 10, so 7 by 2, in that way also you can calculate, but being it is simple one, I am not eliminating the decimal point. 7 in 3.5, 35 5 times, so 3.5, 0.5. Okay, so 22 into 5 is 110, so 1 decimal place, that is 110, 1 decimal place should be shifted to left side, so 11. Okay, so 11 into, hope this is clear, 12.5 plus 7 is 19.5. Again decimal multiplication, so without decimal multiply 195 with 11, that is 5, 9, 1, 5, 9, 1. Okay, then 5, 4 plus 1, 1 and 1 remainder carrying, that is 1 plus 1, 2145, and 1 decimal places should be shifted, so 214.5 centimeter square. This is the TSA of the toy. Okay, by adding the CSA of the cone with the CSA of the hemisphere. Okay, in the fourth question we have given a cubical block. Okay, and a hemisphere is mounted on the topmost face of the cube. And here we have asked two questions. What is the maximum, is greatest diameter that hemisphere can have? Okay, and what is the TSA of the solid? That is the two questions we have to solve for this question. Okay, yes, we can think of the first question. What is the maximum diameter, greatest diameter of the hemisphere can have? Okay, so let us assume this is a cube, okay, having 7 centimeter side. Okay, and I am keeping a hemisphere. Okay, this is a hemisphere I am placing over the topmost face. You can see that some portion is left over. That means you can definitely place a hemisphere with a greater diameter than this. Okay, if I am keeping this one, children, okay, let us see. After placing this hemisphere, you can see that the both, that means the diameter, means it has two endpoints. Okay, the diameter, the both ends are exactly touching the both ends of the cube. Okay, that means the diameter must be equal to the side of the cube. That means the greatest diameter can have for a hemisphere is equal to the side of the given cube. Here the side is 7 centimeter. So the greatest diameter is equal to, what is the first greatest diameter equal to? Okay, diameter equal to side of the cube. That is equal to 7 centimeter. Is it clear, children? Yes, in the second part, what we have to find out? The TSA of the solid. That means when you keep that hemisphere over the topmost face. Okay, the solid is like this, I already told. Okay, so we have to find out the TSA of this entire solid. Okay, so here we have to be very careful. When you are keeping this hemisphere over the topmost face of the cube, okay, the area which is equal to the base area of the hemisphere, okay, that is covered, okay, from the topmost face. That should not be considered when you are taking the TSA. That area which is equal to the circular face, that is base area, that is pi r square. Okay, that should be subtracted from the total surface area, that is 6a square, and there is no change for this other 5 faces. Okay, and the only change goes to the topmost face. But we can take the entire solid, the area of the cube, that is 6a square. But if you subtract this area from 6a square, that will be equal to the area of this 5 face, and you can see some portion is remaining here at the 4 corners, even if this hemisphere is keeping. Okay, that will be getting if you subtract this pi r square from 6a square. I think that idea is clear, children. Yes, this is what I said. Suppose this is the topmost face, being it is cube, each face is square shape, and this is the area covered by the hemisphere. Okay, so this area need not be considered, but you have to consider this area, that is 4 corners. You can see these areas should come. Okay, that how can we express? That is TSA of the solid will be, you can take the TSA of the cube, that is 6a square, and subtract the area of the base, that is pi r square. Okay, now you have exact area of this cube and these 4 places. And next what we have to add? We have to add this circular surface, that is CSA of, that is curved surface area of the hemisphere, that is 2 pi r square, 2 pi r square. This will give you TSA of the solid. Okay, after keeping a hemisphere, this is the total surface area of the solid. Understood? Now you just see that in the second and third term, both are in pi r square, minus pi r square plus pi r square. Okay, minus pi r square coefficient is 1, and minus 1 plus 2 is positive 1. Okay, and no change for the first term, 6a square. This can be simplified, and now we have plus pi r square, pi r square, coefficients minus 1 plus 2 become plus 1. Now we can substitute the values. Hope this is clear, children. Yes. Here we have given, that is the diameter of the hemisphere, that is equal to diameter of the hemisphere is equal. We have seen that the greatest diameter that the hemisphere can have is equal to the side of the cube. Okay, that is 7 centimeter, and from this you can easily calculate the radius, that is 7 by 2 centimeter. This is the radius of the hemisphere, because we have to substitute for r square. Understood? And in the first part, the greatest diameter, okay, equal to the side of the cube. Okay, cube, and that is equal to 7 centimeter. And this is the second part, that is TSA. So now we can substitute 6 into A means side. Okay, this is side. Okay, A, that is given as 7 that is 7 square plus 22 by 7 into 7 by 2. We have seen R as 7 by 2 into 7 by 2. Okay, Now 6 into 49, 7 square. 7 get cancelled. Okay, and 2 and 22 11 times. So plus 11 into 7, 77 by 2. By multiplication, 49 with 6, 6 nines are 54, 5 carries, okay, 6 fours are 24 plus 9, 29 plus 77 by 2, we can divide, okay, 2 in 7, 3 times, okay, 1 carrying to 7, and that is in 17, it is 8, 16, then 1 remainder, and in 10, 5. So decimal point. So 38.5. So you can add 294, okay, plus 38.5, okay, 2, okay, 5, then 2, 1 carry, then 3, okay, 9 plus 1, 10 plus 3, 13, and 1 carrying, so 300, 1 plus 2, that is 332.5 centimeter square. This is the area of the solid. Thank you for watching and supporting my videos. Those who have any single doubt, kindly please comment in comment. I will definitely reply for your any single doubt. Don't feel bad to clear your doubts, children. Okay. And those who didn't subscribe, please do subscribe. Okay. Thank you all.